Before we are going to object oriented Python, like classes and objects, we are going to complete these things, the data structure sides, by by giving an introduction for arrays. So, array in Python. Actually, arrays in Python is a slightly different thing comparing to the list, tuples, and other things in Python. So the main difference is arrays are data structure used to store multiple values of the same type. Lists can store data of different types but are less efficient when working with a large set of data. So the takeaway from this is like if you are using the same data types for all the items, you probably need to choose arrays instead of lists. So some other languages, it's not this case. For example, Java. Most of the times, people will prefer lists because we have a lot of types of lists available in Java. So that's not the case in Python. And also another difference in Java, you can use arrays directly without any import or anything. But in arrays, it's not a part of inbuilt library of Python. You need to import array. Syntax for creating arrays. So array type code a character that defines the type of the element stored in the array. So you need to store different types here, type code, and also the initializers. So you can have multiple values here, and that's it. So that's the way the array will work. We can go to the code right now. I guess this will not take that much time because most of the things are straightforward in this case. So it will not take that much time, but I assume that's the scenario, and you can see. So here you can see array I. So when I print my array, you can see the array I printed to the console. So accessing elements, it's the same way with other programming language, and also the way that we are accessing list, not dictionary. So here you can access first element, that's it, using the zeroth index. Appending elements, that also possible without any problem. So here if I need to append something, that's way easy to do in this code. So just use the append. It's the same for some of the other data structures. It's for the list or something. But here insert 9 at index 2. That's also possible. So here on the index 2 we are inserting 9 here. Add remove an elements. That also same for the other data structures. I to don't need to explain that too much. So slicing an array, that also same to the other things. So you can slice from the index into that one. So if you have no index, what's going to happen in this case? Let's see what's going to happen in this case. We'll work on the same way from the fourth So it will take all the elements until the fourth. So supported type codes: signed integer, float, double, signed character, Unicode character. So these are the things you probably need to remember. The other things are fine. Using NumPy arrays. So for more advanced operation or handling large datasets, Python always using for the large datasets. So NumPy, you need to know this one. So example with the NumPy, you need to import NumPy from the package NumPy. So np, then creating NumPy array. So it's the same like we create an array here, creating an array dot array. That's the same way we are creating NumPy array. So np dot array, and you are adding elements here. So what are the advantages of using NumPy array? So that one thing probably we can check it out. So advantages of using NumPy array. Okay, so let me pull up something. So NumPy array, creating an ID NumPy array. So the main thing, you can have multi-dimensional arrays in this case, but I don't know whether that's possible in the first cases. But this actually prefer two-dimensional arrays. This actually preferred in for the two-dimensional arrays. This actually preferred common operation with the numpys. The dimension of the array size. Okay, so there are so many other operations that's available for numpys. So here we actually created a two-dimensional array, and we are asking like, what is the shape here, right? What is the size here? So here I have 6 total D type here. So let's run this one. So the D type, what the type of the item here, right? So if I am putting some values here, a string here, what's going to happen in this case? So it's saying like U21. So we can have values in that case in that way, and here you can see it's automatically changed into string in that case, everything, not only the one element, but when we are printing with this one with the number, will have only numbers. Basic operation. So what does this mean? Array to shape. So two-dimensional arrays, and each having 3 elements. So if I have more than 3 elements, what's going to happen is, so you can have We need to stick with the dimension. So that's one thing. And here there is some basic operations. I actually forgot to do something here. Let me pull that thing because we need a slide or something to proceed with this discussion. Because it looks like we have something we need, some more discussion we need. So let me pause for a little bit of time. So I'm back. So here uh, our discussion was centered around NumPy arrays. So harnessing the power of NumPy arrays creation operation. So all elements in NumPy array must be the same data type, multidimensional, one dimensional, two dimensional, and multi-dimensional arrays. NT arrays. That's one of the name. Performance and NumPy arrays are optimized for performance, allowing faster computations. So it's not just an array; it's optimized arrays. So NumPy you need to install and you need to import it. Creating NumPy arrays that we already discussed, you can just create in this way, and creating a 2D NumPy array that also we discussed, and shape the dimension of the arrays to 2 into 3. That's total elements of the array size and the data types. What are the data types in that array? Basic operation. So array sum. So this one. So if you have one array, so we are having one array, and you need to add one elements to that one. That's very easy here. You don't need to go to each elements. You need to add separately. Instead of that, you can run in one. You can run in one entry of plus and the sum, right? So element wise multiplication. So that's also possible. Array product, right? So if you are, that's also the same. So the first case you are doing the addition. So the second case you are doing the multiplication. Slicing also possible. It's the same way, I guess. Output 2 element at row 0 column 1. So what does that mean? So here there is some difference, I guess. So here 0 to 1. So it will output the element from 0 to 1. So that's fine. That's nothing we need to worry about. Slicing. These things probably a little bit complicated. So we are using comma here. All rows, column 1. So in a 2D array, we are taking all rows and the column 1. So that's exactly happening here. So that's a very interesting thing. So if you need all the last elements of a two-dimensional array, you will get that. So 2 and 5. So you are checking here 2 and 5 are the first elements of that array. So if I am doing only 0 here, what's going to happen in this case? Whether it's going to work or whether it will throw some exception. So it's still it's still showing me 2 and 5. Maybe I am wrong in this case. Let me check. So right now I'm getting only 5. So the 5 is here in this first array. If you're so this is a starting point. So where you need to start and what you need to get, right? So if you are providing 1, you will get all the elements. So here this is a array 2D column 1. Oh, okay. So basically these two are the same things we are doing, right? So 0 to 1 elements at row 0 column 1. All rows, if you are not providing that one, it will take all the rows and column 1. So it's only difference. Both cases we are using the comma. So that's it about slicing and indexing. Little bit complicated, but you will be better after going through some of the exercises. So reshape arrays. So reshaping arrays means you are changing that dimension of the array, I guess. So array 1D, that's the one we are going to we are going to 5 columns, 5 rows, 1 column. So that's also very good things. So if I am doing something like so stupid things like 6, what's going to happen in this case? Because I didn't have that much element in the array 1. So whether it's going to throw, yeah, it's going to throw an exception. So the array dimension should be correct. If it is not correct, it will be, it will not end well. So that's the thing. So common, there are so many common functions. If you need to find some, you can do that. So here you can get the mean, the sum, everything. So the NumPy. So thank you for watching. This video took some time. Thank you for watching. Have a nice day.